Well, hello today. How are you? This is Mr. Waitley here. Think you know that. Today we're going to start looking at solving equations that have two variables. I'm saying it that way so I can relate it to what we've been doing. It's pretty much an eighth grade standard, and also mixed in a little bit with seventh grade. I think the standard's like 8 EE, something about interpreting a function. Okay, so just go with me on that. But today we're looking at equations that have two variables. How in the world can you solve that? Oh, I thought a car was coming on the road behind me. Oh, hearing things. So it must be the lawnmower. Anyway, hi. So take a look at this, people. You've been doing this. You've been solving equations like this. And I think some of you are probably looking at it right now and you're like, and then you're like, okay, the answer is 2.5, right? Well, how'd you figure that? Because you came up with a number. You plugged in a number that fits, right? There's two ways to solve this. One way is the way I've shown you, right? Opposite operations, -1 divided by 2, it's 2.5. Another way to do it is to take numbers and plug them in for x and figure out which number works. There's only one value there that's going to work. So 2 times 2 is 4, plus 1 is 5. That's not an answer. 2 times 3 is 6, plus 1 is 7. That's not an answer. But if you get to 2.5, 2 times 2.5 is 5, plus 1 is 6. Ah! So I just want you to remember and realize that when you're solving an equation, you're looking for the value that makes the equation true. Okay, nothing new there. That's what we've been doing. You've been solving a one variable equation for quite some time. All right. Well, let's move over, if I can, here to a two variable equation. All right. Now take a look at it. Obviously, we have a variable here and a variable there. And I'm going to ask you the same thing. What are some values that you can plug in to this equation to make it true? In this case, look, we have two variables, right? So instead of plugging in one value, you need to plug in two values. They could be the same amount or they could be different. You tell me. So can you come up with two values that you could plug in right here and both sides would be equal? See? Excellent. Glad you guys did that. I'm going to write down some values. Yeah. I mean, if you put in a 1, 2 times 1 is 2, plus 1 is 3. So 1 and 3 work, right? We plug them in and they make both sides equal. Good. Keep going. You guys came up with a lot. I don't know, 2. If x is 2, then y has to be 5. Good. 3. If x is 3, then y has to be 7. Good. If x is 4, y needs to be 9. If x is 5, y needs to be 11. You getting it? Good. Can you come up with fractions? You bet. If x is 1/2, y is 2. X is 0, y is 1. Can you come up with negative numbers? You bet. You bet. X is -2, then y is -3. X is -5, then y is -9. Good. So these are all considered solutions to the equation. Okay? They are. And we can call these two these two values a solution to the equation. Because if you plug in a 1 for x and a 3 for y, you get both sides are equal. All right. Good. Nice job. So guess what? I'm gonna show you some things. It's not a coincidence. It is not a coincidence that I used X and Y here for the variables. As you'll see on the next page, this X and this Y, I want you to realize, follow the form of an ordered pair, right? Does that look familiar? Let's say 1, 3, 2, 5, 3, 7, 3 for X, Y is 7. You getting the idea? 0 for X, 1 for Y. These are all solutions, we said. 1/2, 2. When X is -5, Y is -9. So are you getting the idea? You getting where we're going with this? We are going to be solving equations on the coordinate plane. I'm going to give you an equation, usually in this form, and you are going to solve it, and you are going to take those solutions and draw them on a coordinate plane. Okay? Oop, beans. Got like an avalanche over here. Sheesh. It's probably Grogu. He's been upset ever since I changed my background. He's like, yeah, I gotta watch out. He might go after my frog eggs. That thing? Yeah. All right. So, oh, look what we have. We have the same equation. And look, now I want you to see this. This is what we just wrote. These are some of the values that we put out there. When X was 1, Y was 3. X was 2, Y was 5. X was 3. Oh, I don't know. I have to plug in the value. So 2 times 3 plus 1, right? I should show you the work. 2 times 1 plus 1. Now, when X is 4, what do we get? I can't remember. I think we got 9, right? We got 7. Good. Hey, do you see a pattern in the table? Anybody? I'll pause. Great. So I'm glad we got the pattern figured out. X is 5, Y is 11, X is 6, Y is 13. You bet. So when this is kind of like Chinese food, if you will, okay? If you can come up with these values, this is called a function table. You've done this. This is like a function. This right here, if you can imagine, I'm doing this, 2x plus 1. We're plugging values in for X, doing the math, and boop, out pops Y. Okay, like a function machine. Any value you throw in for X will give you one certain value for Y. Okay, kind of hard to explain, but it is an 8th grade standard. Okay, so you can plug in 1 for X, and you're always going to get 3. All right, you're not going to get 3, and then sometime later you'll get a different number. It's always going to be 1 Y for the X. And if you put the X's in the table in order in the table, guess what? You'll get order out of the table. It's like Chinese food, order in, order out. Okay? And you notice the pattern. These are going up by, good, every single time. And these are going up by, good, every single time. And you use that pattern. So put your numbers in order here when we do this, so you can use the pattern to find your errors, okay? So I'm just gonna show you then briefly, review with you how to plot these points on the coordinate plane. I'm taking the X and the Y and I'm writing them in this form. This is called an ordered pair. That's 6th grade / 5th grade. So I'm taking these out of the table, the 1 and the 3, and I'm putting them in an ordered pair. 1, 3, we got 2, 5, we've got 3, 7. You don't normally usually do this. I just take them straight from the table, but I want you to see the connection, at least this first time, okay? So these are the points, and I'm going to go ahead and draw them on the coordinate plane. Now, don't forget, please, that this line here, this is the y-axis. Then this horizontal line is the x-axis. So when you're plotting a point like this one here, you're going to start always, you're going to start at the origin right in the middle all the time, every time. You're going to start there, and then you're going to slide, because x is side to side value. You're going to slide wherever it tells you to. And this tells you to slide to 1. So if you start here, you're going to slide. You're not going to go this way. That's -1. You're going to slide out here to 1. Don't drag it. Don't make a mark. And then the second value, the y value, is the up and down amount. So I like to say, okay, you're going to start first by sliding. And the second number tells you where to hop. You're going to go up if it's positive. You'll go down if it's negative. So I'm going to start drawing these points on the coordinate plane. Let's see what happens. So first I'm going to do this one. I'm going to slide 1, hop up 3. So here we go. Slide 1, hop up 3. 1, 2, 3, and I'm going to put a point. Each of these ordered pair creates or make a point on the coordinate plane. Okay, good. Next one is 2, 5. I'll start at 0. I'm going to slide over 2, hop up to 5. I'm hopping up because the 5 is positive. If it were a negative number, I would go down. Okay. All right, the next one is 3, 7. Start at 0, slide over 3, hop up 7. Awesome. The next one is 4, 9. I'll start at 0, slide over to 4, hop up. Oops. I am off the coordinate plane. So you have two options at this point. One thing is just leave it and don't do any more. We have 3 points already. You could pick some of the negative ones if you want, or you could even, if you want, sort of kind of approximate it. If this is 8, then that's about 9, roughly. Okay? Now look what happens. What can you tell me that you notice? Exactly. Good job. So hopefully what you notice is these points fall in a line. And let's see. Yeah, over 1. That's a little closer, I guess. There. So what I just did, people, and I'm going to put arrowheads on the end because look at all these numbers. It never ends. You could plug in an infinite amount of X's and come up with an infinite amount of Y's. So the shortcut is this. You're going to create the table. You're going to plot at least 3, maybe 4 points on the coordinate plane. And then you're going to connect those points with a line. And what this line represents, people, it represents all the points, even ones that we haven't calculated. Everything on this line, let me change the color. Oh, let's go with fancy pink. Every point on this line represents a solution to this equation. So in a way, what this is this is the picture of the solution to this equation. Okay, so just imagine all these points stacking up our solutions and fractions and negative fractions and fractions with whole numbers and all of that. And by the time you draw 9 million solutions, they're pushed together so closely that it looks like a solid line. Okay, so guess what? This is the equation. You used the table, you plugged in numbers, you came up with values, and in turn, you have graphed the solution to the equation. And it happens to be a bivariable or a two variable equation. Okay, it's got a lot of other names too, but right now we're going to do that. Okay? So you will be practicing graphing the solution to a given equation. Okay? Let me show you how to do it. I think you're going to be pretty good at it. Let's start with this one. Okay, so here's your equation. There's the table. I can't find my, there it is. I was going to say I can't find my stylus, but geez. All right. Let's finish this up. I'm going to use blue. All right, so there's the equation. I wrote it that way. This middle part is where you can put the actual function in there if you want. 3x plus 2. I'm going to make it equal y. Now, what I would like for you to do is to use 1, 2, 3, 4, 5. Why not? Use at least 4 numbers for x. And when you do that, put them in order. So let's do this together. -1, 0, 1, and 2. Now, if you'll notice, I put the numbers in order on the x side. Remember, if you put order in, you get order out. It's like Chinese food, okay? And I wanted to put a negative, just, I don't know, just to keep you thinking. All right? Now, look what you can do. 3, and now you may not need to write this down, but this whole middle column, if you want, is where you can do the calculations. So 3 times -1 is -3 plus 2 ends up being -1. So that is a solution to the equation. -1, -1. So when this is -1 and that's -1, both sides are equal. Let's try 0 now. 3 times 0 is 0 plus 2 is 2. So there's another solution. Let's use 1 now. And again, I'll leave that up to you if you want to show all the steps. I'm doing that in my head. 3 times 1 is 3 plus 2 is 5. So 3 times 2 is 6 plus 2 is 8. There's another solution, 2 comma 8. And then we got 3 comma what? Well, look at the pattern. You can tell it goes up by 3 every time. So I just took the 8 and added 3 to it. So here are 5 points. These are 5 solutions to the equation. Are there many more? You bet. 4, 14, on and on and on. Okay? Now we only have certain set numbers here on our coordinate plane, and they're numbered. Okay? So start at 0. I'm going to do this first one. Start at 0, go back 1, and go down 1. It's right here. Why did you go back and down? Because look, negative from the middle is left, and then the -1 is to drop 1. This one shows 0, 2. Look what you do. Start in the middle. Now you're going to slide nowhere. You're going to slide 0, but you're going to hop up 2. And why do you hop up 2? Because the 2 is positive. So I've done that one. I've done this one. Let's do this one. Start at 0, slide over 1, hop up 5. There you go. Here's this one, 2, 8. Go over 2, hop up 8, and I'm right there at the edge of the coordinate plane. So I know that I don't need to go on. I don't need to go further. All right? And look, I have these guys in line. Kind of like that. It's not perfect, but it's pretty close. And I'll put some arrowheads at the end. Girl, something like that. Okay? So what I just showed you now is the graph, which is really, graph means the picture. The graph of the solution to this equation. Okay? And these equations, guess what they're called? Take a wild guess. Okay. These equations are called L-I-N-E, linear equations. Why are they called linear? Well, know, you can probably tell me why they're called linear, because look at that thing. Yeah. If you plot their solutions, they literally line up into a perfectly straight line. Okay, so we'll continue. We're going to do a couple more of these together. Okay, one of these days. All right, let's do another one. Now I left this one blank so we could write our own in.